All right, here we go. This is our final video for Chapter 0. As I've been mentioning throughout the week, we'll have a Chapter 0 test this Friday that'll incorporate all these video lessons that should be, for the most part, review. Remember, if you have questions, obviously class is a really good time for that, but also come in and see me before school, during school, but not after school. So this last video, we're going to talk about complex numbers. And actually, complex numbers kind of splits into two types of numbers. We have over here what's called real numbers. And then we have what's over here, imaginary numbers. Imaginary numbers. Complex numbers take the form a plus bi. So now a real number would be an example of just a, where b equals 0, and imaginaries would be bi, where a equals 0. So complex numbers, like I said before, it looks like a binomial. Well, it is a binomial. It's two terms. You have a, which is your constant, and you have b times your imaginary number, which represents your second term. The first thing I want to get out of the way is understanding imaginary numbers. We have this rule that we follow for much of our time where we cannot take the square root of a negative number. So we devised this solution. Well, we can place these values in this imaginary set of numbers. So if we ever take the square root of a -1, that's where I would come in. So now I squared would be the square root of -1 times the square root of -1, which is just -1. I cubed is just I squared times I, which would be -1 I, and then I to the fourth, which would be I squared times I squared, which would be -1 times -1, which is just 1. And so this pattern keeps going on. So now I to the fifth would just be the same as I. And I to the sixth would just be the same as I squared, which is -1. And it just keeps repeating that pattern. So it repeats the pattern every fourth power. So it goes 1, 2, 3, 4, and then it repeats the same cycle. So it goes I, -1, -I, 1, repeat. I, -1, -I, 1. Keeps going, it keeps going, it keeps going. So here's how we do an example that addresses that. Let's say we want to find the value of I to the 27th. What we would do is we would do 27 divided by 4. Well, that would be 6 with a remainder of 3. The part that we're looking at here is the remainder of 3. Since the remainder is a 3, our value would just become -1 I or -I. If we do another example real quick, we have I to the 100th. So we're going to do 100 divided by 4, which gives you 25 with no remainder. If it has no remainder, that tells us it's the fourth one, which would be just 1. And then if we do one more example, I to the 13th, we're going to do 13 divided by 4. 4 goes into 13 3 complete times with 1 left over. So that tells me it goes to I to the first power. So this should just equal regular I. Multiplying and dividing follow a lot of the same rules that we would with radicals. So I think we don't need to spend a ton of time on this, but if I were to multiply 3 minus I times 2 plus I would distribute my 3, so that would be 6 plus 3I. I would distribute my negative I, which would be negative 2I minus I squared. I can combine my like terms here, which would be I. So here's what I got now. I got 6 plus I minus I squared. Well, I squared gives me negative 1. So 6 plus I minus negative 1. This acts as a plus. And my answer is 7 plus I. That's very, very similar to how a radical would be. Our middle terms would probably have a radical in them. I could combine them because they'd have the same radicand. And then I just have to look at the last term and recognize the relationship that when I multiply the same radical with itself, that it gets rid of the radical symbol and I'm left with just a number. Same idea with I squared. Similarly, if I take a dividing complex number, I want to use what's called the conjugate. So I look at the denominator and I see that it's a plus. So my conjugate would be 1 minus 3i. And the rule that we have to follow here, we don't want to leave an imaginary number in the denominator or a complex number in the denominator. So I'm going to multiply top and bottom by my conjugate. So my numerator, I'm going to distribute here. That gives me 2 minus 6i. I'm going to distribute my negative I here, so that gives me a minus I plus a 3i squared. My numerator is going to simplify to 2 minus 7i minus 3, which becomes negative 1 minus 7i. So that right there is my numerator. And I'm going to follow the same idea in my denominator. And that's going to give me 1 minus 3i. And then I'm going to distribute this in. And that gives me 3i minus 9i squared. Remember, this is all my denominator now. Clean that up a little bit. These middle i's go away. I squared is a negative 1, so that's plus 9. My denominator just becomes 10. So my numerator is highlighted in yellow. My denominator is highlighted in green. So I have negative 1 minus 7i divided by 10. What I'm going to do now is I'm going to split that 10 to each term. And there's my answer. Very, very comparable to dealing with radicals. All in all, not a whole lot new going on here. A lot of it should be connected to the things that we've already done. If you have questions, please bring those to class tomorrow while you're working on the assignment. I will certainly be around to check in on your understanding and see where I can best help you. Good luck.